CNC routers need some kind of fixture plate to hold the actual workpiece. Some are mere spoilboards where parts can screwed in, some have T-nuts or threaded inserts for hold-down clamps or even a vise, and some use vacuum for holding the parts. Today I show you how to make a fixture plate that combines all these features in one. And if you're interested to see how I work on a part using all these different possibilities, watch till the end. Hello and welcome to my channel. I'd like to start right away with a tip which always applies when you have a gantry style router, regardless whether you use a fixture plate or a simple spoilboard. Never use just one big plate in the size of your machine bed. Never, ever. Gantry routers have a dead spot under the gantry in its homing position where the spindle cannot reach. Unless you use this spot for a fancy retractable ATC magazine, this remains usually empty. So when you have to face the board, eventually even multiple times, this leaves a positive step in the area. But one benefit of gantry routers is that you can machine parts which are much longer than their bed length by simply pushing the part further in multiple operations. And this is not possible anymore when you have a step on the table. That's why you should ideally use a fixture plate just in the size of the actual work area and close the dead spot with a thinner plate, creating a negative step. And in case your board screw is under the table, this gives you as well a service opening to grease the board screw nut without the need to remove the entire board. I made my fixture plate out of POM, which some of you may know as acetal or Delrin. There are several reasons why I prefer this rather expensive material for a woodworking router. First of all, it is easy to machine, even though it makes a terrible mess, as you can see. POM has a nice warm touch and is softer than aluminum, but it is still durable. On my old machine, the threads survived more than 2 years before I sold it without any issues. After all, you do not have to tighten your woodworking parts with a crazy torque to the table anyway. And a plate of that size in aluminum is also rather difficult to handle from a weight point of view. An alternative would have been MDF, but that would have required adding some 1200 threaded inserts. And on top, MDF is permeable, so for a vacuum table it requires some extra sealing treatment. And finally, POM doesn't swell, so any unnoticed drops of grease won't harm the plate. And I still have the option to add an MQL to the machine in the unlikely event that I want to mill some other stuff than wood on it sometime in the distant future. I started the actual fixture plate directly on the new machine, but due to the lack of any means to hold the part, I ended up with a rather sketchy setup. With hindsight, it would have been far easier to use hold-down clamps and the existing M8 threads in the machine bed, but for whatever reason why, I chose these woodworking clamps to fix the plate to the bed. Maybe I felt this to be more appropriate because this is supposed to be a woodworking router, I don't know. I first drilled all the M8 through holes and then the 2 half-inch threads for the L fittings of the vacuum ports. And please apologize the poor video quality here, but it turns out that the plexi window of my enclosure is as well a halfway decent mirror. At least this way you get a glimpse of the junk that normally occupies my workbenches. The next task then was to thoroughly clean everything from those nasty little POM chips, which tend to stick everywhere due to the electrostatic adhesion. After this, I could connect the vacuum hoses and finally flip the plate. I have 2 separate ports that can be opened and closed with a plug in the table, and the connection to my pump is done with a 1-inch hose. For this table size, this is more than enough. The table is then roughly aligned to the bed with a parallel and fixed to the bed with half of the M8 bolts. Then the countersunks are milled of the other half, and the bolts are changed and the remaining countersunks milled. Another little trick that I can share is how to close the gap between the gantry side plates and the fixture plate, so that chips and dust cannot fall in between and slowly damage your linear blocks over time, because this area is rather difficult to clean and usually forgotten anyway. I use some 3mm thick felt strips with an adhesive on one side. This stuff normally goes under furniture legs to protect wooden flooring from scratches. The distance between the side plates and the fixture plate is about 5mm, so I 3D printed a thin carrier strip to bridge the remaining gap. It also makes the assembly and alignment of the felt strip to the side plates much easier. This works perfectly fine for any wooden chips and dust, but the combo withstands as well the occasional drop of coolant from an MQL. And then finally the fun began. I milled exactly 1231 M8 threads. I started with an 8mm hole about 7mm deep. This can be used for dowel pins so that I can align workpieces and as well my modular vices perfectly parallel to my axis. In that hole I milled in the second op a 25mm deep 6.8mm hole for the M8 thread. This is then milled with a thread mill from -24 to -7mm, which gives me about twice the bolt diameter as thread depth, which is a good value for POM. I have the exact same principle in the fixture plate of my big machine, and this has proven to be the most versatile pattern. It takes quite some time to make, but it is a one-off effort and well worth it. And the holes are milled and not drilled because I do not have any coolant on this machine, and drilling POM is prone for bird nesting. Also, with this high count of holes and no coolant, the drill gets hot rather quickly, and this bears another risk for clogging with molten POM. But as you can see, the machine is quite precise and mills nice and round holes, which give a perfect fit for dowel pins, even without drilling. Once the hole and thread pattern was done, I faced the plate and took about 0.5 millimeter off to make the surface perfectly flat and aligned to my gantry axis. And this, I can tell you, really creates a mess, but the chips are big and were therefore easy to clean. The last thing to do was to mill the vacuum channels. I started with the outer parameter and then milled the horizontal and vertical channels in one go. That is by far the easiest way to create a 25 by 25 mm grid pattern. And this is how the finished blade looks like. Quite nice, isn't it? So, let's test it with a typical use case of this CNC router, planing a rather irregular shaped and warped slab of hardwood. To fix the slab for the first side up, I use these Modular Vices. They are basically a copy of the SMW Mod Vices. I made them some time ago with some small variations, mainly to fit into a metric 25 by 25 mm pattern, and also in 5-inch width and not in 4. But when you live in the Imperial world, I can highly recommend you get the original ones from SMW directly. They are fairly priced and it is not really worth the effort to make your own. These here are made out of A303 stainless steel. My first version of them was in 7075 aluminum, which is as hard as it can get in alu, but after a year of usage, the loose jaws were basically scrap. Due to their working principle, they just won't last very long if not made out of steel. But they're extremely flexible to use, and you can see here, for example, that the loose jaws are not parallel to the fixed jaws, but rather align themselves to the contour of the wood slab. Facing such a warped piece of wood means you have a lot of idle toolpaths until you finally hit the highest spot. This means you need to take a rather aggressive approach in terms of feed and chip load, otherwise it takes forever. But since this is my first test, not only of the machine but as well of this particular face mill, I started rather conservative with a feed of 4.5 meter per minute, 2 mm depth of cut and 42 mm step over. I used the manual feed override on my control panel to quickly run through the idle parts until finally the first chips were made. With the first side done, I wanted to test the other main functionality of the table, the vacuum holding. But first I had to remove the chips with a shop vac. In case you wonder why I don't use a dust shoe on this machine, this was explained in detail in my last video about my enclosure air filtration system, which I have linked in the description below. The slab, by the way, is made out of pear wood, and I really love to work with this. In order to create a sealed area for the vacuum, I have to fill a 5.5 mm thick EPDM foam cord into the channels. The fine 25 by 25 mm grid allows here to match the shape of the workpiece quite closely to get as much pressure surface as possible. And then it was time to crank up the milling parameters. I finally settled for a feed of 9 meter per minute and a cutting depth of 4 mm, still with 42 mm step over, which is about 70% of the cutter diameter. This thing is called Tornado and it really is a beast. I have as well a link in the description below in case you want to know more about it. And with this, my machine is finally done. Thanks for watching, and please let me know in the comments below what you think about it. If you haven't seen the build series from start to finish yet, you'll find it in the playlist. And if you like this video, give it a thumbs up, subscribe to the channel, and hit the notification bell so you don't miss the next videos. Stay tuned and see you next.